This video emphasizes the importance of understanding the working principles of an emergency electronic ballasts, beyond just knowing how to wire them. When installing an emergency electronic ballasts, it's important to avoid common mistakes that could lead to system failure or safety hazards. Always follow manufacturer's installation guidelines and turn off the main power supply. Emergency ballasts typically contain internal or external rechargeable battery, charging circuitry, and control electronics housed within a compact enclosure. They are crucial for safety in commercial environments such as offices, hospitals, classrooms, and warehouses, where they provide light during power outages. Now, let's get down to how to interconnect both the regular and the emergency ballasts in real life, with our redrawn diagram, ensuring safety and continuous illumination. Let's first analyze the details on each ballast, focusing on the frequency and voltage, and how combining both ballasts may involve connecting the output terminals of the emergency ballast to the tube lights alongside with the regular ballast connections. We have a diagram on each ballast that illustrates how to wire the tube lights, with open termination points for merging both ballasts. At the moment of turning on the switch, the electronic ballast accepts a 50 to 60 Hz supply AC voltage, which is converted to DC, and then filtered using a capacitor arrangement before being supplied to a high-frequency oscillation stage, which outputs a square wave in kHz, resulting in maximum output voltage to initiate the gas discharge process in the fluorescent lamps. After the lamp is lit, the voltage across the lamp decreases significantly to the manufacturer's voltage and amperage ratings. Understanding the importance of each component, from the rectifiers to the oscillation stage, helps you to know why certain lamps are used and how the ballast supports them. Also, why the connections are made a certain way, and not just that they should be. Now, let's assume these are our primary connection and secondary connection terminals for the regular ballast, and these are for the emergency ballasts. X1, X2, X3, and X4 are the terminal blocks for both tube lights 1 and tube light 2. The tags with arrows pointing down or up are the interconnecting lines, or wires between the two ballasts and the tube lights. For example, let's say RB represents regular ballast, TL1 and TL2 represent tube lights, and EB represents emergency ballast. RB4, with the down arrow, means the number 1 terminal of the emergency ballast is connected to the number 4 terminal of the regular ballast with the tag EB1, arrow up. TL1 is connecting to EB2 on X1, terminal 1 or 2. X1, terminal 2 is the link between EB4 and TL1. EB6 is connected to TL1 on X2, terminal 1 or 2. And EB8 to TL1, terminal 2. RB1 and RB2 are connected to TL2, X3, terminal 1 and 2. The remaining connection points would be wired following the same logic or method. On the primary side of the ballast, connect a direct live wire to the unswitched terminal marked L and neutral wire to unswitched terminal marked N of the emergency ballast. This is a constant power supply that bypasses any switches and provides continuous power to the emergency ballast, allowing it to charge the backup battery and be ready for use at any time. Connect the backup battery to the ballast, ensuring proper polarity, red to the positive terminal and black to the negative terminal. From the power source, attach a switched live wire to the live terminal and connect from the live out terminal to the terminal marked L1 on the regular ballast. This allows the emergency ballast to send power directly to the regular ballast when the switch live is on, and in case of an emergency, it will provide power from its battery reserve. Finally, completes the circuit for the continuous power supply by connecting neutral to the L2 of the regular ballast. Remember to ground the circuit at all time. Here's how it works. When you turn on the light switch, the main power flows into the emergency ballast through the switch live in terminal. The emergency ballast then sends this power out through the switch live out terminal to the L1 of the regular ballast lighting fixture, turning on the light. If the main power fails, the emergency ballast stops receiving power at the switch live in terminal. The emergency ballast then automatically switches to its backup battery power and continues to send power to the regular ballast lighting fixture through the switch live out terminal, ensuring that the light stays on during an emergency. If you're working on installing or servicing these systems, always make sure all connections comply with the National Electrical Code and any local regulations. Remember, safety first. Would you like to learn more about integrating the emergency ballast with the main fixture? Well, if you found this video helpful, don't forget to give it a thumbs up and subscribe to our channel for more educational content. If you have any questions or suggestions for future videos, please let us know in the comments section below. Click the bell icon to receive notifications and stay updated.